Welcome to the Explainer. We're surrounded by numbers, and today we're going to take on one of the biggest ones you see every single day. We're going to find a way to dig deeper and uncover the real story hiding in the data.
All right, so let's just jump right in. Think about it. We use the word average constantly. Average test scores, average temperature, you name it. But is it actually telling us the whole story, or is it hiding something?
Okay, check this out. We've got two classes here, and get this, both of them have the exact same average test score, 80. But just look at them. They couldn't be more different. One class is super consistent, everyone's bunched right up around that 80. But the other class, whoa, the scores are all over the place. The average all by itself completely misses that huge difference. It's clear we need a better tool to really see what's going on. So how do we get past that one single number? That average that can sometimes be so misleading? Well, we need to find a way to talk about the spread of the data. And that's where our hero for today comes in, the interquartile range, or IQR for short. The magic of the IQR is actually pretty simple. Instead of looking at all the numbers, it zeroes in on what we could call the middle ground, that core 50% of the data where things are the most consistent. All right, so finding this middle 50% sounds pretty useful, right? But how do we actually do it? Let's break down how to calculate it. It's actually a pretty straightforward three-step process. Let's use this set of numbers right here: 5, 8, 12, 16, 20, and 25. Step 1, we find something called Q1, the lower quartile. That's just the middle of the lower half of our data, which in this case is 8. Then step 2, we find Q3, the upper quartile. You guessed it, the middle of the upper half. That's 20. And the last step, super simple. You just subtract Q1 from Q3. So for our little data set, that's 20 minus 8, which gives us an IQR of 12. And that number, 12, tells us the total spread of that core middle group. It's basically the range of the most typical values in our list. Numbers are great, but you know what they say, a picture is worth 1,000 of them. So now let's see how we can actually visualize this idea using a really cool tool called a box plot. A box plot is built from what's called the 5-number summary. It's just 5 key pieces of info. We've got the minimum and the maximum values to set the outer boundaries. Then we have our Q1 and Q3 that we just found. And right in the middle of it all, we have the median, the absolute dead center middle point of all the data. Okay, let's actually build this thing. First, we start with the full range of the data. We put down our minimum at 5 and our maximum at 25. These 2 points are going to become the whiskers of our plot. Next up, we drop a line right at the median, which for this data is 14. You can think of this like the 50-yard line of our data set. It splits everything perfectly in half. Half the numbers are below this line and half are above. All right, now it's time to mark the boundaries of that middle ground we were talking about. So we'll put a mark down for Q1, which is at 8, and another one for Q3 up at 20. And now for the grand finale, we just draw a box that connects Q1 and Q3. This box, right here, is the interquartile range. It's the visual of our IQR. You can literally see that core 50% of the data all tucked in there between the whiskers. Okay, so we've got a number and we've got a picture, but why is this so much better than just, finding the simple range from the smallest number to the biggest? Well, this next part is where the IQR really shows its true power. So if we look at our original clean set of numbers, the total range, that's just the max minus the min, is 20. And we already know the IQR is 12. So, they both give us some idea of how spread out the numbers are. But life isn't always clean, right? Data in the real world can get messy. So what happens if we throw in an outlier? A single extreme number that just doesn't quite fit in with the rest of the gang? Okay, now watch this. Let's take our maximum value, 25, and replace it with a crazy outlier, 100. All of a sudden, the total range, which was 20, just explodes to 95. That gives a totally warped picture of our data. But look at the IQR. Because it only cares about the middle, it's completely unfazed by that one wild number. It stays exactly the same right at 12. How cool is that? And that's the whole point right there. The IQR is resilient. It gives you a much more stable, a much more honest picture of what's typical in a set of data, because it's built to ignore those extreme outliers that can throw everything else way off. So you can see this isn't just some clever math trick. It's really a tool for finding clarity. And this whole search for what's truly typical, well, you could almost say it's a kind of wisdom. And it reminds me of this piece of ancient wisdom that says, teach us to number our days, that we may gain a heart of wisdom. It's a really interesting parallel, isn't it? With data, we learn to look past the distracting outliers to find the real, typical story. And maybe in life, wisdom comes from a similar place, from looking past the crazy highs and the deep lows to really understand the true, consistent substance of our time. So the next time you see a statistic, the next time someone throws an average at you, I want you to remember the box plot. Remember to ask yourself, wait a minute, what's happening in that middle 50%? What's the real story here once you look past the extremes? And I'll leave you with this final thought. What middle ground is the data in your own life trying to show you?